I do feel like everything I'm getting ready to go through today is review. At this point, I'm probably just going to keep teaching if some of you leave, even if I'm just keep teaching to a couple. Get it on video. You can always go back and see the video, get notes from a friend if you have to. Okay? So that's kind of where I'm at right here. The first thing, vertex form of an equation. Okay? Vertex form is this one right here, where you can see the vertex. Remember, the vertex is HK. And then that A value out front represents your vertical stretch or vertical shrink or vertical compression, however you want to say it. So in this form, remember your vertex is HK.
Can Mr. Bonanzo's second hour period come to the auditorium? And then can I get National Honor Society and National Junior Honor Society from the auditorium? Thank you.
Sorry.
I said that. I said, you guys start talking. Yeah, no, that's what that's.
Okay, well, I'm still going to teach, and I will review. I'll go back and review where I need to for people when they walk back in. But put your phone out there if you need to.
Can I have it?
Yes. Okay. It's not a stupid question. It's just.
It's a good question.
It is. Okay. Okay. So there's some of the basics. Vertex is HK. Axis of symmetry. Remember, it's the first number in the vertex, right? Okay. We can find the axis of symmetry using the equation. They say H equals negative B over 2A. It's the same thing as saying X equals negative B over 2A, but that right there is your axis of symmetry. Remember, once you know that X value, you can find the other half of the vertex. Normally, what do? We normally, once we know the first half of the ordered pair, we plug it in to find the second half. And that would be what K equals F of H represents. This is specific to, I think it's in this book, yeah, that's just still my notes from the previous book. But another way to find the Y value in the vertex is this K equals C minus AH squared. It's a random little formula. On occasion over the years, I've had people that prefer this formula rather than plugging the X value into the equation. Okay, so that's something you could do. And then I think you guys know, if your A value is greater than 0, so if A is positive, my parabola is going to open up. If that A value is less than 0, so negative, then the parabola opens down. Okay? So, our example here asks us to use standard form, which I didn't really mention it, but standard form is ax squared plus bx plus c, right? Use the standard form, which is what they provide, to find the vertex and axis of symmetry of the graph of f of x, and rewrite the equation in vertex form. Now, in this case, they're asking us to use formulas. What do we need to first be able to recognize about this equation? It's written in the wrong order. Let's put it in standard form just so we don't get confused. And what does she mean wrong order?
Isn't if the X power needs to be the
yeah, highest power to lowest power, right? So I'm going to rewrite this to be negative 3x squared plus 6x minus 5. You guys want to humor me and tell me my ABCs?
No.
Negative 3, 6, negative 5.
Nope, you got it. And the only reason I mention this is because order does matter there, yes? If you didn't catch that the x squared term wasn't first, you just messed up your ABCs, which messes up the entire problem. So that's the reason I pointed out here. Okay, so they ask us to use standard form to find vertex and axis. So let's start by finding the axis of symmetry. Well, if your equation is in standard form, the easiest way to find the axis of symmetry is our formula up here. Okay? So I always say x equals, it's also h equals because it's the first number in the vertex, right? So the negative of b over 2a, which is what? Negative 6 over 2 times negative 3, which is? Which is?
1.
1.
Oh, yay.
Okay, nice numbers.
See, that's the math we always need. We need more complicated.
Okay, so my axis of symmetry is x equals 1. It's also my h value if you want to think that way. Now, we haven't done this year, right? I'm making you go back to a year ago. We haven't dealt with this type of stuff really this year. Okay. So once you know your axis of symmetry, what about vertex? What do I know at this exact moment?
Your H.
I know my h, yes? If you ask me what my vertex is at this exact moment, I'm going to say 1 comma something. I don't know my something yet, but I know it's 1. And remember, that connection is always there, isn't it? Okay? That your axis of symmetry value is always the first number in the vertex.
No matter what.
No matter what.
I make sure.
Okay. Now, from there, how do we find the second half of the vertex?
Be honest with you.
So is this the one where we either plug it into the one, like the weird random one, or plug it into the regular one?
You can, what you know right now is to just plug it into the original equation.
So you can plug it into that one.
Or you could try out this c minus ah squared if you wanted to. Okay, that is an option. I'm going to stick with, so it was f of x, so I'm plugging in 1, right? So I'm just going to say it's negative 3 times 1 squared plus 6 times 1 minus 5. Negative 3 plus 6 minus 5, which is...
Okay, I'm going to ask a stupid question. So, okay, so you know we got the one, like the x one, right?
Mhm.
Does it matter which one we plug it in for the fx over there? Like, does it matter if we...
Which of these? No.
Okay.
Either or. I just picked the one that was in standard form out of habit, but there's nothing that says you couldn't have picked the one of how it was written on the paper.
I had to make sure.
Yep. So now what do we know about our vertex? Vertex is 1 comma negative 2. Now, I don't know. Emily, you sound interested. Did you try it?
The National Junior Honor Society and D&D Club come down in the auditorium. Thank you.
Okay.
I think there's 3 of them.
Okay. So you could have tried this. This is your other thing that could have worked. C. This is just a side note. C is negative 5 minus A, which was negative 3, times h squared. So 1 squared. So this is negative 5 plus 3 times 1, negative 5 plus 3, which, hey, guess what? Is negative 2. I showed a lot of silly steps there, but if you want to remember that formula and use that, is that an option? It is.
That one looks more easy.
So it's just the key is it's another formula you have to know, whereas here it's just plugging into the
So
given
during
problem.
the test, it doesn't matter which one we use?
Nope.
Okay.
Just know why. Okay, what did they ask me to do? They asked me
Should we write the equation?
to find the vertex and the axis. We did those, right? And rewrite the equation in vertex form. What's vertex form?
Big bold one.
Okay,
What
the
we
big
have
bold
there.
one at the top. So, vertex form. Here, I'll write the form and then we'll fill it. F of x equals a times x minus h squared plus k. So, f of x, and sometimes you put y, that's fine. A. What's a?
Negative 3.
Negative 3. It's just that a from there times x minus h, x minus 1, quantity squared, plus k
Minus 2.
minus 2. Okay?
So when we get the formula for that, like during the test,
I don't
I
remember.
would say, should we memorize that? Because I think it was on,
because I'm not going to memorize that.
I know in Algebra 2.
In
it
Algebra 2 was on a formula page.
But I know this year, that might not be the same case.
I don't think, okay, so come back to this question when I give you the review worksheet.
Okay.
Okay? Because what I often try to do, because I don't have a formula sheet, as much in, second semester we have some papers, but I don't really have formula sheets much to speak of first semester here in pre-cal. I might provide them like in the directions with that section.
Okay.
Does that make, like on the test?
Yeah.
That might be what I've done in the past, but again, I don't have my review worksheet. Well, my review worksheet ready to go because I always use the same. I don't have my test ready to go. So, but that's something I would do the same form I've done in the past.
Okay. Just wanted to make sure.
Yeah. Okay, this sounds familiar, yes?
Yes.
So hopefully your classmates will think it sounds familiar once. Okay. Now, there's another way to do vertex form. You guys act like this is going to be bad.
This was the stuff that I never really understood.
We can use completing the square to also write vertex form. Now, we did do a little bit of completing the square in chapter P this year. Okay. I don't know, we did it in Algebra 2. I don't know if you were still in there when we did it or not. So it might be in between for you, but okay. So they're asking us, use completing the square to describe the graph of f of x equals 3x squared plus, whoops, that's a big issue,
What?
12x plus 11.
Oh, come on.
Is that fixed on your guys's? I thought I had that fixed. It is fixed on yours?
No, that's a plus sign.
Yeah. I am
Okay, I really thought I had it fixed on the notes. That's why I'm confused. Because I really thought I had it fixed, and I just didn't. Okay. Now, so completing the square. Basically, we're going for vertex form again. Okay. Now, I don't know what you guys remember about completing the square, but we are looking to start off getting in the form x squared plus bx plus c.
Can we have book club and yearbook to the front of the auditorium, please? Thank you.
Okay.
Well, there goes one.
Another one bites the dust. Have fun.
So x squared plus bx and then the plus c. So that's the first thing we got to do is we want to put it in that order. Now, okay, so f of x equals, in my parentheses, I need x squared plus bx. Out of my parentheses, I need the c value. Now, what's the catch?
Is this the one where we subtract the 11 over?
Okay, don't go there yet.
What?
Yeah, okay, hold on.
I can't remember the steps.
Okay, well, okay, and here's,
I hear Thomas.
okay, the subtracting 11 over is going to happen if this was solving an equation using completing the square.
But no, we're writing
Okay.
a function.
And so, as we look at this,
Just two.
You guys took forever.
I know, we stood there for a while. We've not done anything super strange.
okay, we're down on example 7 if you join me there, please. Okay, join me on example 7. I've got to keep moving. Okay. Example 7, we're using completing the square to get to vertex form. For those of you that just walked back into the room, let me remind you, vertex form is a times x minus h squared plus k. And I'm reminding you because those of us that were in here talked about vertex form on the last example. You guys missed that example. It's not bad, I promise. It's what you did definitely in Algebra 2. Okay? Now, we're trying to get to vertex form, but our required method this time is completing the square. Last time we just got to use our negative b over 2a formula. With this in mind, to complete the square here, what I was starting off saying is I need my equation rewritten in the form x squared plus bx in the parentheses, leave a gap, and then the plus c outside the parentheses. And what I was trying to, before we heard you guys walking down the hallway, is there's a slight catch here. What do you notice with this x squared? What's not in front of it? There's not an ax squared in front of it, is there?
Did you add an x to it?
I did. Yes, sorry. That's a typo. Your x is missing on the 12. I really thought I had it fixed in these copies, but I can see I keep forgetting to get it fixed. So yes, that is supposed to be 12x. That was a typo. Okay, so notice there's no a value. Do I have an a value here? I do. So how are we going to get that 3? Whoops, what did I just do? How are we going to get that 3 off the x squared? We're going to factor it out. Okay, so here, I'm going to do this in an extra step. I'm going to write it, first of all, as 3x squared plus 12x. I'm going to leave a gap and put my plus 11. Okay, I'm going to take baby steps, sorry. Now, the catch is I have an a value, and notice there is no a value here, right? So we're going to take that 3 and factor it out. Nice thing is, does it factor out of the other term nicely too? It does. We only factor it out of the parentheses, so just leave the 11 as is. So I'm going to say 3 x squared plus 4x, leave a gap, plus 11. Leave a gap in your parentheses, plus 11. Now, we have a formula to complete the square, and that formula is b over 2 quantity squared. Okay. What's my b value?
4.
My b is currently, and that's what you've got to catch, yes? My b is currently 4. So we're going to do 4 divided by 2 and square it. 4 divided by 2 is 2. 2 squared is 4. Okay. If we were solving an equation, when we completed the square, you would add 4 on the left and add 4 on the right, if you had 2 sides of the equation to work with. Here's the catch on this one. I don't have 2 sides of the equation to work with. We are going to add the 4 in our gap right there. Okay? Now, when we add the 4 in the gap right there, okay, adding the 4 on the other side of the equation would be adding it over here with f of x, which is just kind of weird. So over here outside of the parentheses, to keep my equation balanced, if I add the 4 here, we're going to do the opposite, and we're going to subtract the 4 here. Okay? So there's 2 different ways, and we did these in Algebra 2. There's 2 different ways we completed the square. One was if you're solving an equation, and you have x squared plus bx on one side of the equation, c on the other side, we would have added 4 to both sides. Here, because I don't have 2 sides of the equation to work with, we add 4 in the parentheses. Oh, there's a catch. I almost forgot my own catch.
I was going to say the signs.
No? Okay, if we add 4 in the parentheses, we have to subtract 4 outside the parentheses. I'm keeping things balanced. I can't believe I forgot my own catch. Is this just a 4?
No. Huh? 4.
What is this for? What's done to this 4?
Multiply.
It's multiplied by 3, yes? So is this 4 just a 4? No, what is this for really?
12.
A 12. So we have to subtract not just a 4, but a 4 times 3, aka a 12. Can't
Can we
believe
just
it.
write that outside? Can we just subtract 12 on the other
You
side?
could just write minus 12 here instead of minus 4 times 3. I tend to always make it 4 times 3. That way someone's like, not like 12. I have no idea where 12 came from. Maybe you can figure out where 4 times 3 came from.
Could we have class officers and Challenge Cafe at the front of the auditorium, please?
Okay, give me a moment, please. You guys know you have a moment to walk down there, right? Okay, so 3 stays 3. Your job here is to factor. Remember, it factors into one set of parentheses, yes? X squared, this is a perfect square, right? X squared is x. What's the square root of 4? 2. This middle sign is plus, so it's x plus 2 quantity squared. It's the same idea. Basically, what did I just do? X plus 2 times x plus 2. But it's x plus 2 squared, right? And then clean up this. This is plus 11 minus 12, so this is a minus 1. Okay, there is your vertex form. Remember, you can tell me the vertex. My vertex is -2 and -1. You can tell me like there's a stretch, those type of things. Okay, you need to go.
Do I?
It said officers. Are you student council but not an officer?
Yeah, because I was confused. Do I count?
Didn't they already do student council though?
They did like the whole big group. I didn't know if like they were doing like the pictures they put by the auditorium.
I don't know.
Just go
I'm
on
not
down
sure.
there, and if you need me, someone I don't.
Yeah, I don't know.
Okay, they don't care that.
I just knew I had some officers in here. That's why I was asking for a brief moment before. I have no idea.
Set office.
Yeah, class officers.
Class officers.
Oh,
She left earlier, yeah. She took me, when Angela left, that took me down to 2.
Yeah.
So, it's my ever rotating class of,
Who's in your group?
okay. Now, I do have a side note here written in my notes that I'm going to share, that how could we check and make sure we did this right? Using the calculator.
You just do what actually.
An option you could do is you could take your original graph and your new graph, and you could graph them on the calculator, and what should happen?
They should line up.
They should line up, yes? Okay, so a check option is to graph original and new equation I'm just going to say to make sure
Oh, dang, I gotta fix this.
they are the same. Am I saying you have to check?
Yeah, they are the same.
Okay. They better be the same.
Just saying.
I mean, I hope I caught all my mistakes here. That's why I had to keep an answer key in front of me to help me catch mistakes there. But yeah, if I graph 3x squared plus 12x plus 11, and then if I graph 3 parentheses x plus 2 quantity squared minus 1. I have my blue parabola and my red parabola traced my blue parabola. Okay? So that's an option. If you're like, yeah, I have no idea, I don't feel confident about my completing a square, it's an option. Okay? Questions on this one? Did I get you guys caught up that walked back in?
I like
Okay.
the first one better.
Is example 6 kind of like this?
It uses, I'll go back to it here at the end if I have a moment. I want to make sure I get,
Yeah.
we have one example on the back side, then I'll backtrack to that one. Okay. Example 8 on the back. Given a vertex of 3, -5 and a point of 2, 1, write the equation for the quadratic function.
Watch.
This is something we did in Algebra 2, because my Algebra 2 kids just did this last chapter. Now, it just says write the equation of the quadratic function. We're going to use the form that we have been using of the vertex form f of x equals a times x minus h squared plus k. Now, I said f of x. What's f of x the same as?
Y.
Yeah, this is the same thing as saying y equals a times x minus h squared plus k.
Could we have Reagan Bakery in the front of the auditorium, please? Thank you.
See? They'll call your name if they need you. Okay, now, what we have to know. In order to write this formula, we have to know h and k, and we have to know a. What do we already know? Okay. We know h and k. How do I know h and k?
Like the first one.
-3 and 5.
Given a vertex, remember vertex is hk. So I know h and k. Emily said I also know x and y.
1 and 2.
Do I really need to know X and Y?
You just plug it in.
Well, here's the deal. What do I really need to know? I really need to know A.
A.
Do they give me A?
No.
No. How can I find A?
You gotta plug everything in. Solve for A.
Plug in H and K and X and Y, and then solve for A. And then we'll have information to write our final answer. So, let's do it. Y equals, so I'm going to say 1 equals A X minus H. 2 minus -3 quantity squared plus K plus 5. You guys okay with my plugging in there? 1 equals, now be careful here. What is 2 minus -3?
5.
5. What's 5 squared?
5 plus 5. 30. Oh, no, wait a minute. No.
5 squared is 25, and what's 25 being done?
25.
It's 25A plus 5. Don't follow Luis's lead on that one. You went one step too far.
Trust.
What do I do to solve for A now?
Subtract 5.
Subtract the 5 over. But thank you, Luis. You did make the common mistake that I needed everyone to not do. Okay, you're preventing that mistake, I hope. 1 minus 5 is -4 equals 25A. Divide by 25, and A is a lovely -4/25.
Oh, what?
We're done. It doesn't matter. Okay, so our job was to write vertex form, yes? Okay. Here's vertex form. F of X, or Y equals whatever, equals, what's A?
-4 over 25.
-4 over 25 times, now, what do I put for X minus H?
There's still more.
I'm just writing my final answer.
X plus 3.
X minus -3, which is indeed X plus 3, quantity squared, plus K,
Plus 5.
plus 5. Okay. Does X and Y go in my final answer?
Yeah.
Only in the form that we used them to find A. Okay? Okay. I'll go back and touch base on what I can for who's in here and whoever needs, but everything's going to be in the video, right? And I'll get that posted later. The homework, page 163, 13 through 18 all, I have watched vertical axis. I think like the horizontal axis counts by 1s, but the vertical axis of the graphs you're looking at or something counts by like 5s or something funky.
Okay.
And it just, so watch vertical axis and then 24 through 44 evens. And this homework is due tomorrow. Okay?
Tomorrow's a 1-day lesson.